Unit 4, Congruence, Midsegments and Medians. A midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. Every triangle has 3 midsegments. So it joins the midpoints of two sides of the triangle. So the midpoints are here of each side, the midpoints in the middle. And so these are the mid segments that are joining them, and there are 3. 1, 2, 3. So the mid segments in this triangle are X, Y, X, Z, and Y, Z. So these right here are the mid segments. 2, 3. So at the bottom of the page, we have the triangle midsegment theorem. It says the midsegment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. So here's your midsegment, DE. It's parallel to side AC, so therefore this is half the length of this. So again, DE, because it's parallel to AC, would be half the length. So if AC was 8, DE would be 4. Let's try some examples. Example 1, it says find BD. So BD is equal to, so there's BD, it's parallel to side AE. So it's 1/2 of side AE. So BD equals 1/2, and down here it tells us that AE is 17. 1/2 of 17. So if you do that out on the calculator, you're going to get BD equals 8.5. Because again, this midsegment is half the length of the parallel side. Example 2, find JL. So JL is here. So that's the side of the triangle. So the midsegment PN we see is 36. So if PN is half of JL, then JL is going to equal 2 times PN. So JL equals 2 times 36. JL equals 72. Because the side of the triangle is double. Because remember, this is half of that. Example 3. Find PR. So PR down here is this side. Okay, and then we know that DE is half of that. So PR is going to equal 2 of these. So PR is 5 plus X. So you're going to set it up. So PR equals 2 times DE. So that's how we're going to set it up. So 5 plus X equals 2 times 2X minus 11. So now we have to do a distributive property here. So you're going to get 5 plus X equals 4X minus 22. So then we're going to take, we could do minus X. 5 equals 3X minus 22. Add 22. Get 27 equals 3X. Divide by 3. So then you're going to get, so then that's 9 equals X, so X equals 9. So now we have to plug that back in because it says find PR. So PR equals 5 plus X. So PR equals 5 plus 9. PR equals 14. Next page. So it says a median of a triangle is a segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. Every triangle has 3 medians. So again, it goes from the vertex, a vertex, and then it goes down to the midpoint of the opposite side from that vertex. So this is a median. So then it says the point of concurrency of the medians of a triangle is the centroid. And if you want to pause and take a minute to write this down, it's when 3 or more lines meet at a point, they are said to be concurrent. So, again, the point of concurrency of the medians of a triangle is called the centroid of the triangle. This is always inside the triangle. So then we have the centroid theorem. So it says the centroid of a triangle. So this is the point where they meet, the medians meet, okay, is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So in other words, this part here is 2/3 of this whole line. This section's 2/3 of it, and this section would be 1/3 of it. So same thing here. So if the whole thing was 9, then BP would be 6, that's 2/3 of it, and PZ would be 3, and the whole distance would be 9. So again, just to reiterate that, this whole median is BZ. BP is 2/3 of that, and then ZP would be 1/3 of that. So if BP was 20, that's 2/3. We know this is half of that. This little line has to be half of that because it's only 1/3. So that would be 10, and the whole line would be 30. Let's do some examples. So it says, example 4, in triangle JKL, ZW equals 15, find KW. So this section here equals 15, so I will mark that down. So KW is going to equal ZW plus KZ. We need this piece to get the whole length. So if this is 1/3 and this is 2/3, so this part here is half of this part. So that would make, if we know that, then we know this part is 30, because this is 15. So it would be KW equals 15 plus 30, so then KW equals 45. Example 5, in triangle LMN, RL equals 21. So RL, this whole median here is 21. And SQ is 3, so I labeled that. It says find LS and NQ. So we know that RL is going to equal RS plus LS. This plus this is going to equal the whole thing. So we know that RS is going to be 1/3 of 21. So RS is going to equal 1/3 of 21. In other words, 21 divided by 3. So we know that RS is going to equal 7. We need to find LS, though. That was the thing. So we know RL is 21 equals 7 plus LS. So then we can, so this is 7. I mean, you know right away by looking at it, this is half of this. So we know right away, you can say that LS is going to be 14. But if you want to do the math out, it would be 21 equals 7 plus LS. So when you subtract the 7 from both sides, and LS is going to equal 14. But this, whatever this line is, it's 1/3 of the whole. This value is 1/3 of the whole line, and this is 2/3. So this is half of this. And then they add together to make the full line. So LS is 14. Now we have to also find NQ. So they gave us SQ. So NQ is the whole line, and SQ is this little piece. So NQ is going to equal SQ plus NS. NQ equals 3 plus, so if we look at this, so this is 3, that's 1/3, so this is the 2/3, so this is going to be double this. So it's going to be 6 here, so NQ would then equal 9. Example 6, in triangle RST, SB equals 3x minus 4, 3x minus 4, and BF equals 2x minus 4. So we know that BF is half of S, so we could say SB. So we could say SB equals 2 times BF. So then when we put that in, we'll substitute 3x minus 4 equals 2 times 2x minus 4. So we're going to have to distribute here. So 3x minus 4 equals 4x minus 8. So then we can solve from here. We subtract the 3x, subtract the 3x. Negative 4 equals x minus 8 plus 8 plus 8 to both sides. 4 equals x. So we get x equals 4. So then it says find SB though. So SB equals 3x minus 4. So we know we're going to plug in 4 for x. So it equals 3 times 4 minus 4. SB equals 12 minus 4. SB equals 8. And that's it. Have a good day.